So please welcome Charlie Liu.
First of all, I would like to thank you for the opportunity to talk about load balancing with session persistence. Also about the opportunity to use one of the extension header in IPv6 packet to do more efficient load balancing and more robust session persistence in an IPv6 world. My name is Charlie Liu from Charter Communications. Charter is the fourth largest cable operators next to Comcast, Time Warner, Cox, but we are quite sizable. We serve about 5 million customers, residential and business. About the load balancer, it's a common technique we use to ensure high availability and good performance in a web-based applications. It has evolved from this simple DNS round robin to a very sophisticated ADC application delivery control. Many cable operators have literally hundreds of load balancers. The number of load balancers in a major financial institution like Wells Fargo can reach as large as 1,000. And it's also possible when you are scaling out your server farm with the help of load balancer, you find yourself that you need more powerful load balancer to handle more connections, more traffic. So it's natural to ask whether there's a way to improve the performance of load balancer so that it can handle more connection, have a higher throughput. Usually when we talk about session persistence, it means that you want to direct all the traffics from a single client in a single TCP session to the same server, unless you have something in the back end to glue different connections together. However, there are circumstances that the session persistence is not that easy. We are going to talk about that. And also today, one of the limits of the throughput in server farm is limited by the fact that both the traffic from the client to the server and the traffic from the server back to the client has to go through a single device, load balancer. And of course, there are some exceptions like DSR, direct server return. Here is one of the scenarios that it's not easy to do session persistence. For example, in enterprise or ISP network, there could be a proxy server, mega proxy, that a client access the application will open multiple TCP connections. And those different TCP connections can actually go through different proxy servers. And the load balancer will have some issue to deal with the fact that you need to direct those different connections to the same server, because a proxy server, mega proxy, will replace the source address of the client to its own address. So the load balancer actually see two different IP, and it would thought that it would think that that's two different clients, and therefore the application can get broken. And can also happen that there are many connections come in into the load balancer with the same IP address, because proxy server proxy and change the IP address of the incoming traffic. And the load balancer will send all the traffic to the same server. And in that case, you don't have a good load balancing there. And we talk about this one. E-commerce application particularly require session persistence, particularly when you are transitioning from HTTP to HTTPS. There are many ways that we can do the persistence. For example, as I mentioned, you could have a backend storage or a backend database and use that as a glue so that you can still maintain the state information. Or you can have some middleware that glue multiple servers together so that it would look like a single server. And probably the most common is use SSL accelerator. The traffic will be redirected into the accelerator and decrypt it and send it back to load balancer. And because now the traffic is unencrypted, therefore the load balancer can look into the packet, particularly the cookie, and use that as a tool for persistence. But it's important to note that in wireless internet, for example, the smartphone, the cookie usually turned off by default. So this mechanism of cookie switching would not be valid in that scenario. And I'm going to talk about that the destination header in IPv6 packet could be used as a mechanism for session persistence. IPv6 is coming even slowly. It's slowly coming. But according to Google IPv6 statistic, we know that the adoption rate is about 10%, a little bit less than 10%. And we expect that that adoption rate is going to increase. By the time next year, it's probably will be around 25%. So V6 is coming, and it makes sense that we look into a way that we can improve the load balancing in the upcoming IPv6 world. And the destination option is defined in RFC 2460. Its format is as such. I believe everyone is familiar with this. You define the options, the option type, and then the option length, and then it's of the information going to be contained in the options. And here is a proposal that we would define an option. It's called load balancing session persistent options. By the way, the destination option can only be examined by the destination node. So here, we look at this picture. Earlier, we talked about if this is an IPv4 traffic, because the different TCP connection issued by the same client could go through different proxy servers, and it could be sent to two different servers. However, in the IPv6 world, we can have something that called destination header, so that when the packet is sent to the server or to the VIP of the load balancer, it will include the destination option. And there are two fields in destination option. One is IPv6 address of the client. And the second field is responding server's IPv6 address. So when the packet the first packet sent from the client, it will feed in its own V6 address in that destination option in the first segment of that LBSP. And the server, of course, it doesn't know which server will take that traffic. It will leave it all zeros. And when the packet goes through proxy servers, it's not going to change the information in the destination header, those LBSP option data. However, the proxy is going to use its own V6 address as a source address of this packet before forwarding it over to load balancer. And when load balancer see the packet, it doesn't have to go by the source address of the packet. Instead, it can go into that destination header to look at the source IP address, source IPv6 address, so that you can still have this source address persistence there, and they can be sent to the same server and maintain your session persistence. Here is a picture. So when the packet is framed by the client, the web browser, it would include the LBSP option and send it to proxy servers. Could be forward proxy or could be transparent proxy. And the load balancer, when the load balancer get this packet, it's going to look at this source IPv6 address, not the source IPv6 address of the IPv6 packet, but the IPv6 address in that destination header. Because at this point in time, the destination address of that packet actually use a VIP address of the load balancer. So the load balancer is a destination. It has a right to examine that destination header. And therefore, the packet will go, no matter whether that's going through proxy 1 or proxy 2, it will go to the same server. And when the packet returned by the server is going to write its own V6 address. And remember, in most service provider, actually, we are going to use global routable V6 address for the servers. And it will put into this LBSP options and send it back to load balancer. And then the load balancer is going to forward that to the proxy server and then back to client. When the client receives the packet, that packet has that LBSP option data field. It has the address of the responding server V6 address. So when it sends the packet, that HTTP request packet over to server farm, it will include that destination header. And the load balancer is going to see that. And here, because that responding server's V6 address is in the packet in the destination header data there, the load balancer can simply just forward the packet to the load balancer, to the server, indicated by that address. With this possibility, the load balancer actually doesn't have to do delay binding. That's a common technique that load balancer use to solve the issue of mega proxy in enterprise network or in ISP network. Okay, so this part kind of a self-explanatory. And here is the illustration of how the load balancer do session persistence if it worked the way that we just described. For the first packet or the first 3 packets for TCP connection setup, the load balancer has to make the decision based on the V6 accuracy and also other criteria such as health state of each server using this weighted this connection algorithm to choose the server. But once the server is decided, when the packet send the HTTP request, the load balancer will have an easier time in terms of deciding which server is going to send the packet to, because that information is right there. And when you go to do this HTTPS, say you do some online shopping and is about to do the checkout to feed in your credit card information, then this will come in handy. If this destination header is placed before those encryption header, then the load balancer can see it easily and know where to send the packet. Of course, in this case, that SSL decryption has to be done by the server itself. And if you do have that SSL accelerator, this destination header actually can be put behind the encryption header, because the packet is going to be routed to accelerator, get decrypted, and sent back to the load balancer. And in this case, then that V6 address of the client and also the server address can be seen, can be read by the load balancer, and you can maintain your session persistence easily. So there are multiple ways that the IPv6 can help to get a more robust session persistence. As I mentioned earlier, that wireless phone by default turn off the cookie. So the old way of using the cookie to do session persistence is not likely to work. Incidentally, today most wireless phone is dual stack, and they can do IPv6 traffic easily end-to-end. In fact, some service provider probably will do the translation of V6 traffic into V4 before it leaves their own network. And I'm interested to see if there's a possibility actually we can have the traffic going through load balancer once and once only. Pretty much like in the old day, if you use a DNS round robin, you just need to do the DNS lookup once, and then you cache the information. So it will be possible if we have such a topology in the data centers. The load balancer is not in the direct path between the client and the server farm. Instead, the traffic will go to load balancer and then come back hairpin back to your distribution switch, layer 3 distribution switch, such as a Nexus switch, and then come back into the server farm. Because the client already had the responding server's address, it can actually, in the following transaction, it doesn't have to use the VIP address of the server, of the load balancer. Instead, you can use the V6 address of the server directory. And there might be security concern here. Here's the way it works. As before, the V6 traffic will be sent through proxy and reach the server. Server send the traffic back through load balancer back to the client. And now the client knows the responding server's V6 address. The screen is a little bit too far away from me. I cannot see very well on the screen here. Okay, let's back up a little bit. So here's a packet from the client to the server. And then the packet returned from the server back to the client. And at this point,
yeah, just you've walked away from them.
okay.
Yeah.
At this point, the client already know the server's address, so you can send the packet directly to the server, bypassing the load balancer. And the packet will be sent back to the client without going through load balancer. So the requirement to the client, the web browser, will be to cache that responding server's V6 address and use it in subsequent packet sent out from the client to applications, to application servers. And in fact, both the client and the server can decide whether you want to do that. If the server doesn't insert its own V6 address into that LBSP options, then the client doesn't have that information. It will continue to use the VIP address of the load balancer. And the scenario will be pretty much what that we described earlier. And if the server send back that address, then the client has the option to go directly to the server. So the server itself actually can make that decision to see whether he wants to go this route or not. And this is pretty much all I have today. Question?
Looks like we've got a question in the middle, Mike.
Good morning, Matt Petak from Yahoo. So if I understand correctly, you're going to open a TCP socket using the VIP address. It's going to get forwarded to a real server. The real server sends back its own IP in the LBSP header, and then somehow that TCP socket is going to magically jump from the VIP address it was bound to over to the real server's IP address?
I think the server web browser can do that, right? There's probably some stitching that you need to do, but I believe this is something possible. You can still keep that TCP section alive, or you actually issue a new TCP connections.
I think you would have to issue the new TCP connection. I don't think we have any magic TCP socket jumping yet, but it's a nice idea. Thank you.
Okay, thanks.
Hello. Hi.
Oh, one more over on the left.
I'll try to
Oh,
do it.
sorry. My
Um,
right. But.
John Christoph from Team Cumry. Interesting idea. It's a little complicated for my taste, but the one, I guess I'll say one nice thing about it is it appears that trying to remove some of the fate sharing from the network by moving it up into a protocol layer, which may be nice. But the one thing that seems to stick out for me, not maybe knowing enough about this, is how do you prevent against spoofing attacks in that next header now? Because that next header then is not going to be inspected by any of the routers, maybe not the proxy server, or maybe you do have to do it by the proxy server. And how is it going to know if it's spoofed or not?
Okay, security is not addressed here. I do realize it's a possible pitfall, but if you are interested, certainly we can work together to see whether this something could be useful, right? And in fact, if you are sending a packet to your application, your own IPv6 address should be good, right? But of course, as the gentleman mentioned, that someone could spoof the V6, the address on that LBSP header, and no one really expecting it. Yeah, that's something we can talk about.
Okay, thanks very much, Charlie.
Thank you.